Welcome to the properties of operations, which is pretty much the mathematical rules and laws. We are excited today because these are fun and we're going to enjoy it. So your learning target is I can identify and use mathematical properties to simplify algebraic expressions. Okay. So essentially what we're doing today is we're going to take a look at some of the rules, or they're called properties of mathematics, and kind of dissect them and understand what they mean. It's kind of elementary. We know what these mean. We've seen them before, but we're just going to apply it with technical terms, okay? So the first one we're going to do is the commutative property of addition. And essentially what the commutative property of addition means is that the order that the numbers are added together will not change the sum. So in symbols, what that means is a plus b is going to equal b plus a. And we see that because if we try this out, let's say a is 4 and b is 3. 4 plus 3 is 7. And if we switch that around, we do 3 plus 4, we get 7 again. Okay, so the order of what we add isn't going to change anything. Okay, so let's now do the commutative property of multiplication, which is no different, except it's multiplying. In words, the order of numbers are multiplied together will not change the product, because a times b is equal to b times a. And if we check this out again, we should use 4 and 3 again. 4 times 3 is 12. And if we switch that around, 3 times 4, we know that's 12, okay? So this is something that's very simple. We've seen this a ton. It's just kind of applying words to it, okay? So you need to know that when the order doesn't matter, we're talking about the commutative property, whether that's the commutative property of addition or the commutative property of multiplication. Both stand true, okay? Let's move on to the associative properties. The associative property of addition states that the way numbers are grouped together when we add will not change the sum. So essentially, if we were to put symbols to that, we are saying a plus b, in parentheses, plus c is going to be equal to, I'm going to write this portion down below here, a plus b plus c in parentheses. So b plus c are in parentheses, plus a, and then a plus b first, plus c. It's not going to change the order, is essentially what the associative property of addition says. So if we put in some numbers here, let's say a is 5, and we're going to say b is 2, 5 plus 2, and we'll call c, we'll say that's 3, okay? If we take the sum, we have 5 plus 2, that's 7, plus 3, that's going to be 10. Okay, now if we test it out the other way, so we regroup it as 5 plus 2 plus 3 first. So 2 plus 3 is 5, plus 5 equals 10. So both stand true. And then the associative property of multiplication is exactly the same thing, except we're multiplying. So we say that would be a times b in parentheses, so multiply those first, then times c is going to equal a multiplied by b times c first. Essentially, that's what the associative property of multiplication says. It says the way that the numbers are grouped together is not going to change the product. So if we test this out and we multiply 5 times 2, then times 3, well, 5 times 2 is 10, times 3 is 30. Or if we multiply 5 times 2 times 3 first, 2 times 3. 2 times 3 is 6, and 6 times 5 is 30. Okay? So the way that the numbers are grouped when we multiply or when we add doesn't change. And that is what the associative property is all about. Whether it's the associative property of addition or associative property of multiplication. Those are the two main things. And these four right here are your main bread and butter as far as what we really talk about in terms of properties. The commutative property and the associative property. Those are the two big ones, okay? So let's go on to the additive identity. And the additive identity essentially says that if we add 0 to any number, the answer will always be that number. So that's saying a plus 0 is going to equal a. All right? And so, for example, 5 plus 0 equals 5. So A stays the same no matter what. So if you add anything to 0, it will be whatever you added, or whatever that main number you added to 0 was. Okay, so if you add 0 to any number, the answer is going to always be 0, be that number, and that's called the additive identity. Now the multiplicative identity is if we multiply 1 to any number, the answer will always be that number. So that is A times 1 will always be A. Okay, and we'll use 5 again. Well, let's use 7. We'll use 7 for A. 7 times 1 will equal 7. And so that is the multiplicative identity. It's saying that anything you multiply to 1 is going to be that number. Okay, and lastly, we have the multiplicative property of 0. And what that says is that if you multiply anything by 0, the answer will be 0. So that is A times 0 is going to equal 0. And we know this is easy. 6 times 0, that equals 0, to give an example. Okay, so these are simple rules. We see them all the time, and we know them. We just don't necessarily have words for them. Okay, and that's the important part for you guys to learn today, is what we know over here, these examples, we know those answers, but these are what they're called. And so you need to kind of understand what each of these means and how we use them. So let's do a couple quick short examples just to kind of tell you how you're going to be using this information. Example 1 is to name the property shown by this statement. And this is 3 times, in parentheses, 4 times n is equal to 3 times 4 times n. So what property is this? And if we look back up at our table, we can see that this example uses groups. And the associative property talks about how the groups don't matter and that those are going to equal each other. And so what this is called the associative property. This example here describes the associative property of multiplication because it is a multiplication problem. Okay, let's do the example 2. Okay, example 2 says to explain if the following statement is true or false, and if false, prove how we know that. Okay, and the statement says division has a commutative property. And remember, commutative property was that the order doesn't matter. And so do we think if this is going to be true or false? So let's just test it out, and this is how we will prove it. Is let's take 15 divided by 3. Okay, we know that 3 goes into 15 5 times, so 15 divided by 3 is 5. Now, if it is a commutative property, meaning that the order doesn't matter, then that's saying that the 3 divided by 15 will be 5 as well. And if we do that, we know right away that 15 doesn't go into 3, so we're going to have to put a decimal. 15 goes into 30 twice, so we're going to get 0.2. Okay, and 0.2, or 0.2, is much different than 5. So 15 divided by 3 does not equal 3 divided by 15. Okay, and so this statement is false. And this is what we used right here to prove that. Cool? No, it was a long video. I think you guys did great. Keep up the good work. Peace out. I hope you're still watching the video. Hint, hint.